Hello everybody, today we're going to be doing chapter 7 problem number, we've written this down, number 37. So basically, this is at a construction site. So basically the question is saying, at a construction site, a 65 kilogram bucket of concrete hangs from a light but strong cable that passes over a light friction-free pulley, which is connected to an 80 kilogram box. On this 80 kilogram box, there is a 50 kilogram bag of concrete, and that's supposed to be a bag, but you know, just imagine. And it rests on top of the box. The coefficient of friction, I should probably write this down, the coefficient of friction between the gravel, between the box and the roof are shown. So over here, we have the coefficient of friction static is equal to 0.700, and the coefficient of kinetic is equal to 0.400. So, part A of the question is asking the friction force between this bag of gravel and the box. And that's actually really easy. You don't even have to do any math for that. Considering the fact that this gravel isn't even moving on the box, there's no movement, therefore there's no friction. So the answer to part A is no force, because there's no friction. Now, part B is a little bit trickier. It's saying, so let's read it out. Suddenly, a worker picks up the bag of gravel. Use energy conservation to find the speed of the bucket after it has descended 2 meters from rest. It's a little tricky to do this one, so let's just go ahead and break it down. The first part is we are going to go ahead and find the force of friction, and we can do that with the equation friction is equal to the coefficient of it being kinetic multiplied by the mass of the box times the acceleration of gravity. Go ahead and plug our numbers in, so we get 0.700 multiplied by 80 kilograms, the mass of the box, and this times 9.8 meters per second squared gives us an acceleration of 313.2 newtons. Next, we're going to go ahead and find the change of energy in the system. This can be found by having, because this concrete is going down, we have a negative times the mass of the concrete, 65 kilograms, times acceleration of gravity, times the distance the concrete falls. If you remember, that was 2 meters, and we're going to find the velocity. So, once again, plug in all of our numbers. Get 65 multiplied by 9.8 times 2 meters, 2.0 meters, gives us a change of energy of negative 1,274 joules. And let's see here. We lastly want to find the work of the friction, work done by the friction, and that can simply be found by taking the force of the friction, which we found up here, and multiplying that by the distance that this box moved. So we get negative 313.2 multiplied by 2.0 meters gives us negative 626.4 joules. Now we have everything to use the work energy theorem equation, and that equation is simply, I'll just move over here, 1/2, and for our scenario, it's going to be this section equaling this section. So we get 1/2 the mass of the box plus the mass of the concrete times the velocity squared. Here's the velocity. This is going to be equal to the negative change of energy of the concrete box plus the work done by friction. Go ahead and rearrange this equation for velocity, and we get velocity is equal to, I need a pretty big square root here, 2 times the negative change in energy plus the work done by friction. Go ahead and divide this by the mass of the box. My mistake. So we got the mass of the box plus the mass of the concrete. And we already have all of these numbers since we solved for them up here. And so let's go ahead and plug them in. So we get square root of 2 times 1274 joules. And you see we did ignore the negative. It wanted a negative change of energy, so negative times a negative makes it a positive. And this is the positive work, and this is negative, so we'll subtract 626.4 from this. And of course we'll divide this by the mass of the box, 80, plus the mass of the concrete, 65. Going ahead and simplifying that, we get the square root. We get velocity equaling the square root of 8.93, and plugging that into a calculator, velocity is equal to 2.98 meters per second. Basically, what that says is that when the concrete, when this bucket moves 2 meters down once they lift a 50 kilogram concrete slab off the top of the box, it'll be moving 2.98 meters per second. Alright, I hope that was helpful, and if it was, just go ahead and let me know anything I can do to make it better. Thank you.